The servo motor is powered by the 5-volt power pin on the Arduino. It is grounded on the Arduino through a series of jumper cables here, and then it is pulse width modulated by digital pin 12, as you can see. Then the potentiometer is powered by the 5-volt power strip on end scope to make the servo more consistent. It is grounded also on the Arduino because the end scope doesn't hit 0 volts on ground. It hits like 0.1 or something like that. And then the data from the potentiometer is sent through this white wire to analog 2.
This is the code that translates from potentiometer to servo motor rotation. First we have our variables, this being the pin that the servo motor is attached to, this being the pin that the potentiometer is attached to, this value being the potentiometer output value, this being the total time for the pulse width modulation period in microseconds, and then these three which are used in calculations later. In void setup, we first set the servo pin to being an output and the potentiometer pin to being an input, as well as initiate the serial monitor. In void loop, we first get that potentiometer value from analog pin 2. I then run a calculation that multiplies the potentiometer times the time constant divided by 10 times the max value of the potentiometer that it can consistently reach, plus this offset here to make it so that way the minimum pulse width modulation period is 500. Then the time off, which is just the total time minus time on. And then angle, which I used map on the time on variable, which at its lowest is 500, which I marked as -90, and at its highest is the time constant divided by 10 plus 500, which I marked as 90. And then print both the time on and the angle in the serial monitor. And then turn on and off the servo motor with the appropriate pulse width modulated period, and then delay it for 20 milliseconds to make it more consistent. Here I have the printed angle and the time on for the pulse width modulation period. I delayed it a bunch so that way it's readable and not just an onslaught of numbers, but as you rotate the potentiometer up, the time constant goes up and the angle increases all the way to 90, and then as you go down, the time constant decreases and the angle decreases all the way to -90. And this is what it looks like at full speed.